Professor in Chemical Engineering Department at LJ Institute of Engineering and Technology. The subject that we are going to continue is Mass Transfer Operations 2. So in last lecture we started our new topic, that is continuous rectification. So continuing with the topic, the first part which you have to learn now is reflux. Okay, what is reflux here? We discussed last time also that in reflux a part of top product which is condensed and that liquid which is returned back to the main column, that is your reflux. Now important point here is reflux ratio. Okay, it is called as external reflux because externally from condenser you are sending a part of your liquid back to the column. So what is it? It is known as the ratio of liquid to the distillate. Okay, amount of liquid which is taken back to the column upon the distillate which you are obtaining. So here from the figure you can see it is the top section of your column, right? The vapors, VA is what? The vapors which are taken into the condenser. In condenser what? Your vapors are converted into liquid. So you can see now from right side you are taking out distillate, okay, D. It is what? Distillate. And the left portion is what? L. The liquid amount which is again sent back to the column. So here you can see that the composition is same. Okay, it is just splitting into the streams, but the composition will remain same. So I can say that YA is equal to XD. Okay, your vapors which are condensed, the composition will be same. So that is your reflux ratio. Now the next topic is calculation of number of stages. It is very important topic. Most of your questions are based on this topic. Okay, so basically there are two methods to calculate number of stages. Okay, this method this gives you calculation of number of theoretical stages, right? So the methods are McCabe-Thiele method and Poncon-Severett method. Okay, so moving forward with McCabe-Thiele method, the basic important thing which you have to remember whenever you are describing about this method is, first of all, list out the assumptions. Three important assumptions are there. Those are constant molar heat of vaporization, no heat losses, no heat of mixing. Okay, so based on these assumptions you can say that Vn plus 1 is equal to Vn is equal to Vn minus 1 equal to Vn, same for liquid also. It means the amount, the flow rate of vapor and liquid for all the stages, that is same, constant. Okay, whether it is for n plus 1 plate, n minus 1 plate, the vapor flow rate and similarly liquid flow rate, that would be same. Now let's see how. So you can see the assumption is what? Molar heat of vaporization is constant. Okay, it means, so here you can read that 1 mole of vapor from Vn plus 1 on condensing releases sufficient heat to liberate 1 mole of vapor Vn. So it follows that Vn equal to Vn plus 1. Okay, it means the heat is constantly supplied. Okay, from n plus 1 plate, the vapor, if it will get condensed, the same amount will be utilized to form Vn. So hence your Vn is equal to Vn plus 1. Okay, similarly for liquid also, the flow rate of liquid for different plate would be same. So that was based on the enthalpy balance, right? Here heat balance was done. So you can see on plate N, Vn plus 1 is what? Vapor coming from below plate. Okay, and from N plate it is going on as Vn. So you can see that as molar heat of vaporization is constant, your means heat needed for vapors to vaporize on nth plate, that is supplied by vapors coming from bottom plate. So that is the assumption about McCabe-Thiele method. Now as we saw in distillation column, your column is divided into two parts, rectifying section and stripping section. So now we will study about rectifying section. Okay, rectifying section is also called as enriching section. The first thing which you have to remember here is, so the envelope you can see, that is your rectifying section. Now the material balance which I am doing, okay, I am doing it over the total condenser. Total condenser means it condenses all your vapors into liquid. So you can see what is entering the condenser, G. What is G here? My vapors. Okay, the top vapors are coming out, then it is condensed, and the final output of the condenser is what? Liquid and distillate. So overall material balance is what? Amount of vapor in equal to liquid plus distillate. Entering is what? Your vapor. Leaving is what? Liquid and distillate, right? So this is your overall balance. So now overall balance was what? G equal to L plus D. Okay, Now this is very clear. In top product, in top part, you get your vapors. Okay, you get your more volatile component. So vapors are entering and liquid and distillate are getting out. Now what is here reflux ratio? We studied already. Reflux ratio is what? L by D. Okay, amount of liquid which is sent back to the column to the distillate obtained. Now hence substituting the values, you can get your value of G is equal to D into R plus 1. Okay, it's very simple mathematical relation, it is there. Now talking about component A balance in enriching section. Again, what is your enriching section? The whole envelope, the dotted circle is your enriching section. So material balance of A on that enriching section. Here you can see last part is nth plate. Okay, so we are doing it on nth plate. So on nth plate, what is entering? Yn plus 1 is the mole fraction which is entering. What is getting out? Liquid with mole fraction Xn. So on plate N you can say entering is your vapor with mole fraction Yn plus 1, and the liquid which is going down, okay, it is of composition Xn. So I am doing my component balance now. G into Yn plus 1 is equal to Lxn. Now again, what is again leaving this enriching section? D is leaving. Okay, component balance over whole enriching section. Okay, for in nth plate, entering is what? Vapors with composition Yn plus 1, and the leaving streams for enriching section are what? One is the distillate you get from your condenser, and one is your liquid with composition Xn from nth plate. Okay, so hence what is entering? Amount of A entering is what? G, amount of flow rate of vapor into Yn plus 1 is equal to Lxn plus dxd. Okay, so this is your component balance which you have to remember by heart. So how you can remember on plate N? Remember this way, that on your plate N, Yn plus 1 is entering and Xn is getting out. In exam your questions would be, the data would be given that way, so try to remember your equation as Yn plus 1 and Xn related. Okay, that your vapor is coming from below plate and your liquid is going down from the plate on which you are doing the calculation, right? So now just you have to do the mathematical calculations. Okay, what you did here, that Yn plus is equal to L by G into Xn plus D by G into Xd divided by G. So your final equation is what? Yn plus 1 is equal to R upon R plus 1 Xn plus 1 upon R plus 1 XD. Okay, now you can see how mathematical equations has been done. Okay, you are representing your whole equation in form of reflux ratio. So hence the operating line of enriching section is what? You have to remember these two equations, right? First one is very simple. The second one is what you are doing, you are representing L and G in form of reflux ratio. Here you can see that L by G is what? Is equal to L upon L plus D. G is what? Amount of vapor is what? L plus D, right? So you are substituting it and then carrying out multiply divide by distillate, you are getting R upon R plus 1. So hence these two are the important operating line equations which you have to remember. They are specifically for enriching section or rectifying section, right? Now from this equation you can see what is the slope. Again it is equation of line, so it's going to have slope and intercept. So what is the slope here? You have to remember slope also. L by G is equal to R upon R plus 1. So these two are the slope value which you have to remember. Similarly, what is the intercept? D by G, it is again equal to 1 upon R plus 1. Now your operating line, the X and Y values, what are those values? So remember that way, that on nth plate, one Y which is entering, X which is leaving. Okay, so for that nth plate, these Y and X are the operating conditions. Okay, these are the Y and X value which you have to remember in your operating line. Now similarly for stripping section. In stripping section, what is it? It is the bottommost part. So in bottommost part, what is going down? Liquid is going down. Okay, and from that, so you can see your liquid, L bar is what? Liquid which is coming down. Now reboiler, what it will do? It will reheat. And so what is going from reboiler? You are getting vapors and one you are taking out as your residue product. So what is entering here in reboiler? Okay, for overall material balance over the reboiler, what is entering? Liquid is entering. L bar is what? The bottommost liquid product which is entering. What are the leaving streams? Vapors and residue are taken out. Hence your material balance is what? L bar equal to G bar plus W. One overall material balance, one is the equation which you have to remember. Very easy it is for stripping section because it deals with the high boiling components, right? So of course it would be liquid. So liquid is entering in the reboiler and your vapor and residue are taken up. Similarly, now component A balance for any M plate, okay? So you can see component balance is over this whole envelope, okay, dotted line. So for plate M you can see, okay. So for plate M we are doing the component balance. So you can see from here L bar XM is equal to G bar YM plus 1 plus W XW. From here you can see what is leaving. One is your residue product, okay. Then on plate M, L bar, okay, liquid is coming down from it, and from M plus 1 plate vapors is entering, okay. So over plate M, what is your leaving streams? Your W residue is leaving, and another is that G vapor phase is leaving, and what is entering? Liquid with composition XM. So similarly, entering equal to leaving. So what is entering? L bar XM is equal to G bar YM plus 1 plus W XW. So again dividing it by G now finally and substituting the value of G from above equation, L bar minus W. So this equation is your operating line of stripping section. Now for McCabe-Thiele method, you have to remember equation of reflux ratio, operating line of enriching section, operating line of stripping section. Now, so for stripping section I can say this is your operating line. Again, what is slope here? Slope is L bar upon L bar minus W. Okay, and intercept is what? Minus W upon L bar minus W. See here, don't get confused between L and L bar. Okay, just for stripping section we are introducing a new notation. L bar is what? Flow rate of liquid which is going into the stripping section. W is what? Your residue. Okay, again for M plate, how you can relate Y and X of your operating line? It is YM plus 1 and the leaving is what? XM. Now next topic is intersection of rectifying section and diagonal. Okay, to find an intersection point with diagonal, what you are doing, you are substituting X equal to Y. Okay, because at that point one of the composition, one of the coordinate will be same. So this is what equation of your enriching section. Y equal to R upon R plus 1, X plus XD upon R plus 1. So this is what operating line of your enriching section. Now in this equation, instead of Y, if I am substituting X, okay, then that what does it show? It shows the intersection with diagonal. So hence what is your intersection point which you get? Your intersection point is XD, XD. It means at X equal to XD and at Y equal to XD. At that point, your rectifying section, operating line and diagonal intersect with each other. So hence you can say that thus the operating line of rectifying section is to be drawn on equilibrium diagram through the points XD, XD on 45-degree diagonal with a slope equal to R upon R plus 1 and an intercept of XD upon R plus 1. It is complicated, now using the figure you can understand. So yes, this is what your, first of all it is your for Y versus X curve. Okay, for more volatile component you are plotting your Y versus X curve. You are getting the blue line. What is it? It is your equilibrium curve. The diagonal which is passing at 45 degree. Now the red line, what is it? It is operating line of enriching section. So on diagonal you can see diagonal and the red line, operating line of rectifying section, they intersect. So that point of intersection is what? XD, XD. Okay. So at distillate composition you get your intersection point. Okay, so you can see at 0.95, that is your distillate composition and it is the point where your rectifying section, operating line and diagonal intersect. Okay, again here you don't have to get confused that Y equal to XD. How? Because vapors after condensation, but though it get converted into liquid, still the composition will be same, hence Y equal to XD. So hence you get your point as intersection point as XD, XD. Similarly for stripping section, what you have to do in the operating line of a stripping section, put Y equal to X. So what do you get your intersection point? It is XW, XW. So you can see the operating line of stripping section is to be drawn through point XW, XW on diagonal with slope equal to L bar upon L bar minus W. Hence you can see how operating lines of both the sections are obtaining. Now the red line is what? It is stripping section operating line. So you can see the point where diagonal and this line intersect, it is obtained at XW point. Okay, that is the intersection point. And what is XW? It is the residue composition. Okay, now the slope of this line is what we saw here, L bar upon L bar minus W. So this way you are plotting your operating line of enriching section and stripping section. The next topic is McCabe-Thiele method of obtaining theoretical plates. Okay, so when your distillation column it is designed, right, you know your product specification. Suppose like you have to enrich your A from, suppose the feed composition is 0.3, so you have to enrich it from 0.3 to 0.9. Okay, so you know that your distillate composition you have to keep it as 0.9, right, and your feed composition is given. So based on that, what number of theoretical plates, okay, what number of plates you require to carry out this separation. So a rough approximation is obtained from McCabe-Thiele method. Now note down, it gives you number of theoretical plate, means ideal plate. Okay, the actual number of plates may vary because in theoretical plates we are not taking into account any other problems, whereas in actual conditions certain problems are always there. Starting with the process, the first step is evaluation of distillate, residue, liquid or vapor amount using material balance. Okay, so liquid and vapor also are important here. Okay, so you can, for liquid we saw what happens in reflux, a part of liquid is sent back to the column, so that is the liquid which we are talking about. Similarly, vapor amount also we need to know, so these can be known using carrying out the material balance. The second step is generation of XY data and plotting of equilibrium curve. Okay, your XY data might be given, now you have to draw your equilibrium curve on the graph. Now third step is draw operating line of rectifying section from P, XD coordinate of slope R upon R plus 1. So here you can see that point P is that. What is the coordinate? Okay, it is intersection between rectifying section and diagonal. Coordinate is what? XD. Now from that point you have to draw your operating line of enriching section. So what is line 1? It is rectification section. So line 1 is what? Operating line of rectifying section. So intercept is what again? It is that of rectifying section operating line. Similarly, slope is what? R upon R plus 1. Okay, then your fourth step is now draw operating line of stripping section, again with slope L bar upon L bar minus W. So here you can see you have to be very thorough with operating line equations of rectifying section and stripping section. So in line 2, what is line 2? It is operating line of stripping section. So you can see you are plotting your line 2 from point M. Okay, M is what? XW. So from point M you are drawing line 2. Slope is what again here? L bar upon L bar minus W. Okay, so you will calculate slope, on based on that you will plot your line. Now the main procedure starts from point P. Okay, XD, draw horizontal line to meet equilibrium curve at point A. So here you can see from point P you have drawn a horizontal line. It intersects with equilibrium curve, right? So that is done and we are naming it as point A, right? Now again what you will do, from point A draw vertical line which meets operating line. So you can see first from P what did I did? I draw a horizontal line, it intersects the equilibrium curve. From equilibrium curve, from that point now draw a vertical. So a triangle is formed here, right? It till where I have to draw on the operating line, right? So similarly now continue this process. Okay, continue the formation of triangle. So here you can see that. Now from one point again I am stretching a horizontal, it is meeting an equilibrium curve. From that point drop a vertical till when? Till on the operating line. So you can see on the operating line of line 1. Okay, operating line of rectifying section you are drawing your triangles. Okay, now carry out this till XW is reached. Okay, so see at point 3, what is point 3? It is intersection of enriching section and stripping section. Okay, so now you are drawing your triangles on the operating line of stripping section. You started from where? You started drawing triangles on the operating line of rectifying section. after intersection point of rectifying and stripping section, now you continue drawing triangles on stripping section. So nearmost till when we have to carry out the process of drawing the triangles till XW is reached. Okay. So then last step is what the number of triangles which are obtained here, those suggest the number of stages or plates which are required. So this was the process of obtaining number of stages. It is a graphical method, right? Your whole calculation it is done based on the graph only. So now what are the limitations of McCabe-Thiele method? Okay, it is not used when the relative volatility is less than 1.3 or greater than 5. Again, it is not used when number of plates are more than 25. Okay, and it is not used when the operating reflux ratio is less than 1.1 times minimum reflux ratio. We will study it later what are the types of reflux ratio. Okay, here operating reflux ratio and minimum reflux ratio. But when your operating reflux ratio it is less than 1.1 times minimum reflux ratio, then you cannot use this method. So that was for today's lecture. Thank you.